Hundreds of thousands of researchers around the world are working to improve life and address imminent threats to humanity. Often their research ends up in the scientific valley of death in the form of publications and patents that never see the light of day. That is about to change. Welcome to the Lab to Startup podcast, hosted by Naresh Sunkara, founder and executive director of the Berkeley Postdoc Entrepreneurship Program at the University of California, Berkeley. This show has two main goals: share the stories of those who have successfully founded startups based on their own research, and highlight resources needed to help those aspiring to launch startups in the deep tech space. Whether it's electric cars, vaccines, addressing climate change concerns, or possibly establishing life on other planets, Naresh and his esteemed guests want to help scientists, engineers, faculty, and researchers bring their innovations to market. Learn more and subscribe today at labtostartup.com. And now, here's Naresh.
My guest today is Alexandra Wright Gladstein, the founding CEO of Ayar Labs. Alex met her co-founders Chen Sun and Mark Wade, who were PhD students while she was pursuing her MBA at the Massachusetts Institute of Technology at the time. Ayar Labs is disrupting the traditional performance, cost, and the efficiency curves of the semiconductor and computing industries by delivering up to 1,000x improvement in the interconnect bandwidth density at 1/10 the power. While it might look like a technology company trying to speed up computing dramatically, the underlying mission is about cutting down the amount of energy used in computing, which is a huge climate goal that Alex really wanted to work on. This is one of my favorite episodes and is a masterclass for any of the MBAs out there who are planning to work with technologists. I first met Alex at a startup incubator at UC Berkeley, where we both were working in the same cohort. She is one of the most confident CEOs I've ever met, who successfully led a deep tech startup in the semiconductor and photonics industry, in spite of not having a technical background. There is so much to learn from her journey, and I'm super excited to have this conversation. Hope you enjoy it. Alex, welcome to the show. I would like to set the stage for our discussion by first talking about the problem you're solving at Ayar Labs and the solution you came up with. Talk about the current state of technology around the problem and what was the breakthrough about yours.
Yeah, absolutely. And thank you so much for having me. So the problem that we're solving at Ayar Labs is that computer chips have been getting more powerful over time, exponentially so. If you've heard of Moore's Law, it's this prediction by Gordon Moore decades ago that the computing power that we have available to us on chips would double every year or two, and essentially grow exponentially over time. And that prediction ended up coming true. And that's fantastic for computing power, but what hasn't kept up is how we move data between chips. And that hasn't grown at the same exponential rate. We still use the same type of technology we've used for decades, which is transmitting data over copper wires and copper traces on boards. And that data rate capability hasn't increased exponentially to keep up with Moore's Law. And so it's turned into a real bottleneck that prevents us from being able to make full use of the computing power that we have. So what we've done is we've figured out how to move data between chips using light instead of electricity. It's essentially taking fiber optic communications and miniaturizing down what's on either end of that fiber optic cable so that it can be integrated right alongside a CPU or a memory chip and remove that bottleneck in moving data between chips and really enable new architectures for entire supercomputers and data centers where you no longer have to architect your machine around this limiting factor of the interconnects between chips. And what that does is it makes it possible to increase computing speeds by, depending on the application, 10x, 100x, 1000x, as well as cut down on energy that's wasted. Because, first of all, moving data using light creates much less waste heat. So we're saving a lot of power in the data transmission itself, but we're also saving a lot of power on the compute chip itself because we're making it possible to not have CPUs idle as much as they have until now. Right now, they have to spend a lot of time waiting for data. And when you remove that bottleneck of moving data, you can make better use of that CPU and have it more in use all the time. And that idling wastes a lot of energy. So we actually save a lot of energy just in preventing idling in CPUs as well.
For the sake of audience, let's stick to first principles and talk about how you move data with light. Talk to me as a layman.
Yeah, of course. So the way that you transmit data using light in terms of first principles isn't too different from how you move data using electricity. So you have either a stream of electricity going down a copper wire or a stream of light going down a fiber. And the way that you encode data on it is by turning that light essentially on and off. And this is me very much simplifying it. There's a lot more complicated stuff going on that we have many people with PhDs doing to design this chip. But essentially, we're turning that light stream on and off to encode ones and zeros on it. We do that electrically on one chip to encode the data then optically in the light. On the other end, where it's received, we transfer it back to the electrical domain. So the chips on either end are just transitioning the data from being electrical to optical and then back from optical to electrical, so that you just have the light being used in between chips in that fiber.
Thank you for that. Well, who developed the technology behind this?
To give some context, fiber optic communications has existed for a long time, and we didn't invent that. It's been used kind of as the backbone of the internet for long distance communications for quite a while, as I'm sure most of your audience is aware. Our team came up with a way of miniaturizing what's on either end of that fiber optic cable and being able to make it on the same type of silicon chip where a processor can be made or where memory can be made. And that was really the breakthrough of our team. So the inventors were actually a really big group of inventors, too many for me to name right here. But the lead PIs were at 3 different universities, at MIT and UC Berkeley and University of Colorado Boulder, though that one has now moved to BU. So it's Rajiv Ram and Vladimir Stoyanovich and Milos Popovich. And then a pretty amazing group of grad students and postdocs working within their labs, including my co-founders at Ayar Labs, Mark Wade and Chen Sun. And so Mark and Chen were responsible for a lot of the innovation that took place in the labs before we started Ayar Labs. And they were just graduating from their PhDs as we founded Ayar Labs. And Mark was more focused on the optical design, so design of optical elements on those chips. And then Chen was more responsible for integrating those optics with the electronics and building a lot of the electrical components that control those optics, called drivers. And that group, when I met them, had just invented the world's first ever processor to communicate using light. So this was in 2015, and it was a really big deal. It got published in Nature, which is kind of one of the premier places to get published, and a little more rare, I think, for things in the electrical engineering domain. And it just got a lot of press. It was a really big breakthrough. And the reason that it got all that press was because a lot of people had been working on trying to make optical devices on the same chip as a processor for a long time. And that research had been getting done not only in universities, but also at big companies. And I think it's safe to say billions of dollars had been poured into that type of research across many big companies over time, because it's been known in the industry that we would come up against this bottleneck as Moore's law continued to be successful and we continued to use copper interconnects. It was just generally known we would have to move to optical interconnects at some point in time inside computers. And that's why research groups at all these big companies have been working on it as well. And so it was a very exciting breakthrough to see that it ended up coming to be in the university setting, which was had much less funding, we could say, than the big company researchers.
Maybe to set some context for this breakthrough, give some history about how long did it take for these labs? You said 3 labs were working on this, and it coming out of academia is even more impressive. And just I'll weave in another question of what was the advantage that academia had over industry, because they had been doing this research as well. If you can tell some story around that, that'd be great.
Yeah, so it was 3 different labs. This research project had been going on for 10 years. And the US government, primarily through DARPA, the Department of Defense's research arm, had invested or had granted $20 million to this project over 10 years. So it was a big effort. And yeah, that still is pennies compared to the billion that was probably put in at other for other researchers in the corporate setting. So I think you're right in suggesting that there was some kind of advantage actually in having less funding. I think that was absolutely the case here, because the approach that a lot of the other researchers took was to, the ones who had more resources, was to try to come up with a new manufacturing process where you could manufacture this type of chip. And coming up with manufacturing processes in the semiconductor industry is extremely expensive and extremely hard. This group just didn't have the resources to even begin to do that. So what they did was they just asked the question, can we make an optical transceiver in the same exact manufacturing process where processes are already made today without changing anything about that manufacturing process? And that question seemed to a lot of people to be a silly question because they thought, of course you can't. You don't have the right material set. You don't have the right design capabilities. Why would you try to go do that? But this group said, well, we'll try. And I think it was because they were thinking outside the box in that way that they ended up coming across there are quite a few different breakthroughs that had to happen to get this to work. And I do think it was because they were operating within those confines in the first place.
This story keeps coming up again and again about how not having enough funds makes people more innovative. And let's move on with the story. Like, how did you run into Chen and Mark? Where did you run into them? What happened? Give us a background to how you convinced them to work with you. I'm assuming you're not an engineer and you don't have the technical expertise in the space. Give me some color for that.
Yeah, you're right. I'm not an engineer. I was getting my MBA at MIT, and I went to MIT as an excuse to meet people inventing things that could have an impact on climate, because I wanted to help get a technology out into the world, into people's hands that might not otherwise get there. So I was kind of being this like creepy MBA student trying to meet people in labs. And yeah, it's hard to build trust between people with very different backgrounds like that. And so I felt very fortunate to be at MIT, where there are a lot of different programs and resources to help bridge that gap and build up trust between the different schools at MIT. So the way that I came across Mark and Chen was actually through the PI at MIT, Rajiv Ram. I signed up to be the TA for a class called Energy Ventures. And that was the first thing where when I approached Rajiv, I wasn't saying, hey, Rajiv, want to start a company together? Which, as someone who he had never met would be a little awkward. Instead, I was going to him as the TA of class saying, hey, there's this class Energy Ventures starting in the fall. We put technologies in the class and then put groups of students on the technologies to come up with a business plan over the course of the semester. Do you have any technologies you've developed in your lab that might be a good fit for the class? And Rajiv said, yes, actually I have two different interesting ones in my lab. It's kind of amazing the wealth of different things coming out of his lab and labs in general. But this one happened to be a good fit. So we signed this one up for the class. And then I wasn't a TA during the semester. I was just working over the summer prior to the class. So during the semester, I purposefully just wanted to be a student in the class so that I could work on coming up with a business plan for a technology over the course of the semester. And since I had been finding the technologies over the summer, I got my pick of what technology to work on during the semester. And I was just very excited about this one in particular because of the potential impact it had to really transform an entire industry. And because it can really cut down on the amount of energy used in data centers quite a bit, I think about 50%. And data centers are the fastest growing user of electricity worldwide. So it seemed like a worthwhile time to really try to create a big change in how they use energy. So during the semester, Rajiv introduced me to the other people in his lab and in the other two labs that were all collaborating on this. And that was when I first met both Mark and Chen. Got to know them over the course of the semester, really as a student saying, hey, give me some context on this technology. We're going to set up phone calls with potential customers, learn more about the industries that, might be customers for this. And I got to know them kind of slowly over the course of that semester. At the end of the semester, I had kind of realized that among all the different people in the labs, those two, Mark and Chen, seemed like they could make really good co-founders, and I would love to work with them. So I asked them if they would like to throw our hat in the ring for this business plan competition. Both Energy Ventures as a class and the MIT Clean Energy Prize were just such great resources to have, because at the end of the semester, I didn't have to tell Mark and Chen, hey, do you want to start a company together? Again, which would have been a little awkward. I didn't know them that well at that point. But, hey, do you want to just see if we make it into the finals of this competition was a much less risky ask. And so we applied and we made it into the semifinals, which meant we got assigned 3 mentors. And over the course of 2 months, we worked on improving our pitch ahead of the finals. And that was when we started really getting to know each other and feeling like a team. And we had to incorporate before the finals, in case we won the prize, they had to have somebody to write the check to. That was when we really started to feel like a team and like a business. And we improved the pitch a lot thanks to the mentorship of those 3 mentors. And then we ended up winning the prize in the end, which was the students who run the Clean Energy Prize did a really great job of fundraising that year, because it was a $275,000 prize. I think it's the biggest prize they've ever had for the grand prize. And it was really valuable to us because it not only gave us the confidence to say, okay, we've got something here. These judges believe in what we're doing, so let's go do this. But also the funding was key. We did our first tape out using that funding. A tape out, for those who don't know, the semiconductor world is when you send a design file over to a chip manufacturer and they manufacture that chip for you. And it's very expensive. Startups would not be able to afford it unless there were this system where you can basically share the space on the design file, so that rather than having to take up a full, what's called a reticle, or a full run in the fab, you can just take one little portion of it and you split it with a lot of other researchers and startups. And so we did a tiny, tiny little chip. The smaller the chip, the less you have to pay. And that funding helped pay for that, along with an NSF SBIR that we got shortly afterwards.
Wonderful. So you had this passion for this energy technologies. You were scouting around. I'm assuming this was not the first technology you evaluated. If you've looked at other teams as well, what was it about Chen and Mark that made you think like, okay, these are the people I want to work with? I ask that because you come from a business school point of view, and these are technical founders. If somebody today at a business school is trying to go and look for technologists in the engineering or sciences, what are they supposed to be looking at? And I know Mark and Chen are not here, but from their points of view, if you ever had that conversation, what did they find interesting in you that made them work with you?
Oh, that one's harder to answer. Who knows why they wanted to work with me? I had no experience in the semiconductor industry. I was just this crazy girl saying, let's do this thing. What I was looking for was really 2 things. I wanted to find a technology that would have a big impact on climate change. To find meaning in my life, I need to feel that I'm making a real difference on climate change. That's been true for me for quite a while. And so I was evaluating the technologies based on impact. The impact is one thing, and it's hard to measure impact when a technology is at that nascent stage, right? You don't really know what type of product you'll make with it. And it's tough to quantify when it's at the lab stage. But with this one, it was pretty clear that it had the potential to transform an entire industry, the entire semiconductor industry, and transform how computing is done. And so even if we didn't have complete details, I could tell that this was big and it needed to get into people's hands. It needed to get out into the world. It would just be too much of a shame if it sat on a shelf in a lab forever. So impact was there. Another thing that was really important when it came to the technology was readiness. And that's what I think is the hardest to evaluate as an MBA student. And it was really a learning process. You're right, this wasn't the first technology I evaluated. I evaluated a few other ones from different labs, worked with a few different labs earlier during my MBA. And those were actually great learning experiences because it took me a while. It took me a few months each time to realize, okay, this technology is really exciting, but it actually needs a few more years in the lab before it'll be ready to be spun out into a company. And I think it just took doing it, actually interacting with engineers and learning to speak their language to really start to get a good feel for what makes something ready to spin out. And so I had that experience under my belt when I met Rajiv and Mark and Chen. And so I had a much better feel for understanding readiness. So yeah, I think that was invaluable. And then what was I looking for in co-founders, Mark and Chen in particular? Just people who I enjoyed working with, not big egos, just people who care about making an impact on the world and the success of the company above all else. And people who I enjoy spending time with. And that was definitely the case with both of them. I had a lot of fun getting to know them. And I felt like we could build a team that I would like working with them too as my co-founders.
Right. I'm so glad you told the story about how you actually build trust. You spend the time learning about different technologies and finally evaluating some things like technology readiness and, low ego people you would like to enjoy working with. I talk about that often because, pretty often in business schools, they do this speed dating with technologists and an MBA. I'm like, I don't know how you form teams like that. It's hard for me. I've been through startups, so it's even harder knowing what I know. I hope that is established as a process in business schools where you spend a lot of time with them before you actually found a company. But, moving along, semiconductors and photonics are hard, for me at least, especially if somebody who's not trained as an engineer. I'm assuming Mark and Chen had to spend a lot of time explaining you about the technology and getting you comfortable to the point where you're the face of the company as a CEO. Walk me through that exercise, like your learning process there.
You're right. I mean, it's not just hard for you. I think photonics and semiconductors are two of the most complicated types of technologies that exist, probably. It was a huge learning curve. And who knows how Mark and Chen had the patience to explain everything to me over time. And thank goodness they did, because I had so much to learn. It just took time. There was no shortcut, and it took a ton of patience from them, for which I'm so grateful. It happened over time, kind of casually. We would travel to a supercomputing conference, and at the bar, in the evening, I would just be asking all kinds of questions. How does this work? How does that work? And they'd be like drawing explanations for me on napkins and stuff. It was just, I was continually asking questions. I would say it took probably a couple of years before I got to a level where I could really discuss the technology. And at first it was really, I just had to do a lot of bringing them along with me. I could have an initial conversation with a business person, but as soon as an engineer would be included in a customer conversation, I had to make sure that I had Mark or Chen with me because I couldn't try to talk about that. And then, eventually I got to a point where I knew enough to be dangerous, I guess. I had to remember to still bring in the engineers, so I didn't try to explain too much without them. It was through their generosity, and also Vladimir Stoyanovich, who's one of the PIs. He was the one based at Berkeley, and he spent a ton of time within the company, going on sabbatical, et cetera, from his job as a professor every so often. So it was the three of them, Vladimir and Chen and Mark, who were all very generous with their time and explaining their technology to me.
Took about 2 years for you to get comfortable with the technology, which still is impressive to me, the way you did it. You were dangerous enough that I used to see you at the Citrus Foundry meetings, and I think you are the most confident CEO that I know of around the table.
Really?
So yes. I very, very specifically remember that. And to the point where I'm scared, I'm like, I look like an idiot if I talk to the CEO.
Wow, I had no idea I came across as confident at all.
You did very good. That is much needed. And so you got comfortable with engineering. And talk about the product market fit. Walk me through the exercises that you went over the years, or how much ever time you took. What is the vertical we should be going after first? And, for a deep tech startup, in general, the problems are kind of like defined. Talking about a much broader problem, but when you have to come build a product, I think it has to be very specific. How did you decide on that first product you were going to build, and talk about the market research that you did?
This was a long process and not easy. We were pulled in a lot of different directions. We had a lot of advisors. People with a lot of experience in the photonics industry especially would tell us that we should take a route on the product that we didn't want to take. As I mentioned earlier, fiber optic communications has existed for a long time. And that industry has been disrupted a few times with new startups that come and create a new product that does really well. And so we were oftentimes advised to make another transceiver similar to what other startups had done successfully in the optical space by people who had decades of experience in the industry. And to us, it was clear that that was a safer route to go, but someone else was already doing it. Why would we take this breakthrough technology and make a product that essentially is commoditized, where multiple companies could be making the same product? To us, it was always about solving this problem of communications between chips, not using our technology for longer distance communications like other transceivers are used, but just solving the processor to memory bottleneck where today only electrical communications are used. And because no one else was doing that, it was hard to get the credibility early on, where big behemoth companies that make up the semiconductor space would take us seriously. We required partnerships with the entire technology stack, from the CPU makers like Intel to the companies that actually design the supercomputers, are architecting supercomputers on a bigger level, like an HPE or Cray, all the way to the data centers like a Google or Amazon or Microsoft that are the customers for these things. And as a brand new spin out, it definitely took time to form those relationships and the credibility to where our product could actually be fitting into that technology stack in that way. And I'm proud of our team for having that clarity of what we wanted to do and the change we wanted to see in the world. And we didn't compromise and make something easier and more like what other people had made before. We stuck to our big vision. And we were able to do that through being able to get buy-in from venture capital investors. So we were able to stay true to that vision and have a longer product development pace because we're forming these partnerships and co-developing our product along with big companies like Intel. And it's just a long product development cycle with these companies. So having the trust of our investors to have that long product development cycle because they also believe that we will have this massive impact on the industry was really important. And what made that possible early on was having, in startup speak, they call it your champion, your internal champion. So when we were going, for our seed round, when we were trying to convince Founders Fund to invest in us, they ended up leading that seed round. They, like any investor, wanted to talk to potential customers to see, does anyone want to buy this? And we were able to find champions within some of these big organizations who saw our vision and were excited about it and would get on the phone with Founders Fund and tell them, yes, this is how we want to architect our machines, and the Ayar Labs technology is critical. This is the future. So having that vote of confidence from key stakeholders within the companies that were our customers was really key to being able to raise venture capital, which then funded our ability to develop this really unique product.
A couple of questions come up. One, you mentioned about advice that you receive about going a particular route, make your transceivers, and then you decide not to do that. How did you deal with that? Because this is, generally speaking, when you're saying no to these people or not listening to somebody else's advice, you're stamped as, we can't train this person, especially being a woman. I think it's harder. I've worked with a few female founders and they complained about it. Like if they say no to an advisor, not to oppose a certain route. Did you face anything like that? Or how did you gently respond to them saying no without hurting that relation?
It depended. Some of them I actually quote unquote fired my advisors. If I didn't feel that they were supporting me as a founder and my company with our vision, that was it. I didn't want to be getting their advice. And that definitely did take place. And who knows if there was a gender aspect to it. There very well may have been. I have a feeling there probably was. And I just didn't have time for that. So once I realized that was going on, I moved on quickly, and that was that. In other cases, the advisor supported us as individuals and just was a little skeptical of our vision and whether we'd be able to pull it off, but still had valid advice to give in other arenas, in the more nitty-gritty technical stuff or nitty-gritty relationship buildings with certain companies we wanted to build relationships with. And so I would focus on that aspect of their advice and not worry about their skepticism on the big picture.
You need a lot of clarity to differentiate good advice from bad advice, especially as an early stage founder. How did you pick advisors?
I had an entrepreneur tell me early on to make sure to have advisors who are not investors. And I thought that was very good advice. And the reasoning was you'll always be wanting to impress them. And so you won't want to share the full story. So make sure that you surround yourself with people who don't have that type of skin in the game, where you don't have to worry about sharing the bad along with the good, and where you can really open up with them. So I made sure to do that from early on. I did lean on investors for advice. There always is an aspect of wanting to show the good side of the story to investors. Whereas for these other investors, they came from a number of places. Sometimes I would just meet somebody at a conference who had a ton of relevant experience and who I hit it off with, and I would just stay in touch with them, call them up every so often. Sometimes we would formalize it and put an advisor agreement in place. Sometimes it came through connections. Someone would tell me, oh, you got to talk to this person. They, have experience that's directly relevant to you. And sometimes it came through accelerators or incubators, like the Citrus Foundry. We were also part of a semiconductor focused incubator called Silicon Catalyst. And so both of those incubators were really helpful in getting advisors as well.
On the subject of you convincing them that you're taking this longer route and you're going to need patient capital, if you may call it. How did you broach that subject and how did you convince them? Because investors are looking for quick returns in general.
I never actually broached the topic with any investor so much as just targeted investors who I knew did that type of investing. Most venture capital investors focus on software startups. And what I learned from my first fundraising round, the seed round led by Founders Fund, was that I could waste a lot of time talking to those types of investors who might consider investing in a deep tech startup, but eventually it'd be really hard for them to actually get the conviction to do it. Or I could just focus on the investors who have experience investing in semiconductor and who have that type of patient mindset. So for the Series A, I was much more focused. Yeah, I do a much better job now of qualifying the investors who I speak with and refusing to spend time with investors who don't invest in the right type of company or in the right size of round. There are certain qualification questions I always ask up front before I'll ever do a pitch. And it's, have you invested in this industry before? And what size investment do you typically make? Do you prefer to lead or to follow? And I'm qualifying investors so that I can spend my time efficiently and only talking to the ones that are a right fit for the round.
I want to wrap up this subject of co-founders. I'm assuming some of the faculty were co-founders as well in the company.
That's right.
How was working with faculty co-founders like? And what role did they play in helping you grow the company? Were there any limitations, any good things and the bad things of working with faculty?
So we have 3 faculty co-founders, the 3 PIs who were leading that research, so Rajiv and Vladimir Milosh. And it was important to us early on to have them included as co-founders, even though we didn't expect them to be full-time co-founders like the 3 of us, Mark, Chen, and I were. We wanted to show that we valued all the work they had put into this technology over the prior 10 years. We wanted to maintain strong relationships with all 3 labs for hiring purposes down the line. It was important to us to keep those relationships strong. And so we really wanted them as co-founders with equity. And I will say it was very hard and complicated to figure out equity splits right at the beginning when we were founding the company, because I've never seen a template for this before. I've never before or since heard of a company with 6 co-founders, 3 full-time and 3 part-time. And so we were kind of creating our own charts. And so it was a tough conversation to figure that out. But I think we all did a good job of keeping the goal in mind, which was we want to start a company together. And if we can't agree on equity splits, then there won't be any company. So we had the end goal in mind, which I think got us through that conversation. And I'm really glad that we did, because we have maintained in close relationships with all 3 of the faculty co-founders. And, their involvement has varied depending on the co-founder. Vladimir has been by far the most involved of the 3 because he's taken time off from being a professor. He's worked close to full-time at Ayar Labs during certain semesters, and he was the lead PI on the whole project. So really, if this is anyone's baby, I would say it's most his. And so he's very invested in the success of the company and has just contributed enormously to it. And he's very much a systems thinker. He's getting in there in the room with computer architects, supercomputer architects that are our customers, and working out how to architect an entirely new type of supercomputer with them. Just a really brilliant guy. That's at one end of the spectrum, very involved. At the least, when he was a professor, he was still devoting at least 1 day a week to the company. And plus, I have to say, his 1 day a week, he's basically Superman. I don't know how he accomplishes so much in the limited time he has. So yeah, his contributions have been incredible. I think we've all been very happy that they've been included as co-founders as well, because we include them in strategic conversations, and we have throughout the life of the company. We've been able to have interns from their labs, and those have turned into full-time hires. And we also have even done some sponsored research with their lab. So, we're interested in some topics that we're building a platform at Ayar Labs for manufacturing optical and electrical devices together on the same chip. And the first product we're doing is for communications, but there are all kinds of other really cool things you could do with that technology in the longer term, once we're successful with a communication solution. Things like LiDAR or sensors, anywhere where you could use light and electricity together. We have this amazing platform for integrating those things together on a chip. And because we're not focused on those other products right now as a company, but we are interested in their further development, we've collaborated a bit and sponsored research in the university setting in those other types of topics. So yeah, I would say it's been a really good partnership with all 3 labs. And what's tricky is navigating IP. So we licensed a portfolio of over a dozen patents from the universities when we started the company. And then, it was important to just clearly define where are we doing IP development in the company and where are these professors doing IP development in the lab. And it was just very important to define those things up front so that it wouldn't get muddled in the future, especially because the professors still have grad students working on projects in the lab, and they need to be able to publish, and conflicts of interest could abound. So we've been very careful about being clear about the distinction between different types of research. which has worked out well. But I would say for anyone looking to do something similar, it's really important to have those conversations and put those agreements in place so that everyone understands what's in the academic domain versus what's in the company domain.
Can you shed some light on that? It is a tough process, especially if there's research going on in the academic lab and also in the company, and there's like gray zones. What are one or two things you did right in defining what belongs to whom?
There are a lot of different instances over time. So like early on, for example, there was a conflict of interest. This was just because Mark graduated after we founded the company. So he hadn't done his thesis defense yet. And because his co-founder was also his thesis advisor, what we ended up doing was he had somebody else be in charge of that committee who wasn't actually his advisor to help address that conflict of interest. So there are ways basically of helping address these things, but it's just about being thoughtful about it.
Speaking of licensing, you had to deal with 3 universities. Was one university better than the other? And what was the good and bad experiences?
So it was a big effort to do this licensing agreement. It is complicated to spin something out from 3 different universities. Luckily, there was actually no IP in terms of patents at Berkeley because this was developed in a lab that is part of this group that they don't file patents, basically. It's similar to like, if you've heard of the Media Lab at MIT. Yeah. They don't file patents. Instead, they have sponsors of the lab and they share their work with those sponsors, I think, in quarterly meetings. That simplified things a bit. Another thing was, I'm not even sure anything would have been filed at Berkeley at that point in time because the professor, Vladimir, had been at MIT and he had just very recently switched over to Berkeley. And so he was on a bunch of patents from his MIT time, but had less time at Berkeley. The vast majority of the patents were MIT patents because actually the University of Colorado Boulder professor, Milosh, also had been at MIT. So everyone was at MIT at the start. So that simplified things, that the vast majority of the patents were at MIT. There were a few patents that were co-owned by MIT and University of Colorado. And so what we ended up doing there was putting a joint invention agreement in place, or we didn't put it in place. MIT and University of Colorado Boulder put a joint invention agreement in place for those patents. And we, in the meantime, put an option in place so that we would have the right to negotiate a license on those patents once their joint invention agreement was in place. And it took them 6 months just to negotiate that agreement between them. And then we could then go in and negotiate a licensing agreement for those patents with just MIT as the entity that we interfaced with. So we didn't have to negotiate anything with University of Colorado. It was a license for a portfolio of patents from MIT was essentially what it was.
Okay, so you didn't have to individually go after one patent at a time. It's just a whole portfolio you took after.
That's right.
Nice. Let's slightly shift gears and talk about the fundraising and investors. Talk us through your fundraising journey. Give us 2 perspectives. One, just how difficult it is to raise money in the semiconductor space, and raising money as a female founder. This topic keeps coming up again and again. Some say they had good experiences. Some say they had bad experiences. I don't have a consensus on that. So I'm just gathering your own experiences being a female founder. A non-technical one, I don't know if it was more challenging. Were people questioning before they invest? What was the experience like?
I think the reason you haven't seen a consensus on that question is because it's very hard to know in the moment whether you're being discriminated against. The trends become clear when you look at the macro data. When you look at the trends that women are invested in much less frequently than men are, or the macro trends that minorities are invested in much less frequently. When you look at those macro trends, they're definitely there. But in any one instance, if someone is being rude or if someone passes on around, it's hard to know whether they're doing that because I'm a woman or because they just don't like the idea of the company, or they think, they see something wrong with the company or the technology, or they think I did a bad job pitching. It's just really impossible to separate the reasoning for that. So I would say, based on the statistics, I'm sure I got discriminated against. I must have, right? And I would say also, especially early on, there were some, very few, but there were some overt moments of discrimination where it was very clear that when I was speaking, I was getting talked over and interrupted. And then as soon as one of my co-founders started speaking, they would get listened to with respect. Again, you could say maybe it's because I was non-technical and that VC happened to want to be hearing from a technical person. But, there were some cases where they were asking business questions and not wanting to hear my answers. I say early on because I noticed a big change after the Me Too movement happened. And actually, some of the folks who I noticed that rudeness from ended up getting outed from their firms during the Me Too movement. So there were much bigger problems going on than what I had just experienced with those individuals. So I have to say I'm really grateful for the Me Too movement and the change it created in the VC community. I still think we have a long way to go. There's been a big focus on hiring women as partners at firms, which is insane that until the Me Too movement, it was considered completely acceptable to have all male partners. And now it's somehow, it's great that everyone needs to have at least one female partner, but it does seem like that's where it's ended. Like there's one female partner at every VC firm, and that's it, the token female. It needs to go much farther than that. And the subconscious bias that exists is not cured by just having a female partner either, even if it's all female partners. There also needs to be education. There needs to be some consciousness of the implicit bias, because I, as a woman, I am biased against other women. All women are. That's what the studies show. It's mind-blowing. You'd think because you're a woman, you aren't biased against the pitches you see from other women, but that's not the case. And so it needs to go beyond hiring women as partners. It needs to go into the education so that partners become self-aware. Because what tends to happen, according to the research, is the questions that investors will ask women tend to be different than the questions they will ask men. With women, they tend to dive in more to trying to understand all the risks and the things that could go wrong. Whereas with men, oftentimes they talk more about the upside. They're asking about the potential upside. There's this fantastic TED Talk on the topic. The good thing is at the end of that TED Talk, she talks about how you can actually address that as a founder. So founders who do a good job of taking those questions about downside potential and risk and answering them briefly, but then switching over to the upside potential, those are the founders that get funded more. So to any women out there listening, make sure that you don't spend too much time talking about downside risk and always make sure you go back to talking about upside potential. And that is something I really learned personally as well in my fundraising, learning how to answer Q&A and learning how to keep returning the focus to upside potential really made a difference.
That's a very, very important point. It's easy to get pigeonholed into that risk and go down that rabbit hole, and it's hard to come back. Thank you for sharing that. I think you were at the company as a CEO through Series A or Series B?
Through Series A. The seed round was $2.5 million, and then the Series A was $24 million. And then we brought in Charlie as our new CEO, and he raised our Series B. And we have an announcement coming up soon about the next round.
Well, maybe that's a good segue to talk about your own leadership transitions. You're the co-founder and the CEO. Well, how did you pick the CEO? Was there a discussion like who's going to be the CEO between you, Chen, and Mark?
Oh, a discussion. There were very, very many discussions, and they went back all the way to before we even founded the company. In the same way that we had clarity of vision on what type of company we wanted to build and what type of product we wanted to make, we also had clarity of vision on what type of leadership team we wanted to build from before day one. We decided very early on that we wanted to get the company to a place where it could attract a really top tier leader. My personal goal in life was to be a serial entrepreneur. So to get technologies out of labs until they get to a place where they can be successful without me and then go do the same thing again. And I was upfront about that with my co-founders before we even founded the company. But we also had a worry. We didn't want to have VCs impose leadership on us. And so we decided in choosing our own titles and starting the company, we would own the title, I wouldn't be interim CEO or anything. And we would work on growing the company to a place where it was attractive enough that we could get a really top-notch CEO. And we also agreed that we would never tell investors that we wanted to hire a CEO because we didn't want them to see that as an opening to put their own person in. And we also agreed early on that if we were to hire a CEO, it needed to be somebody who would execute to this vision that we had for the change that we wanted to see in the world, and that we would have 100% confidence on wanting to execute our vision and not shift that vision at all. And someone who we liked, who we enjoyed working with. That was really key to us too, and that the whole company would enjoy working with. So we had tough criteria. It needed to be a rock star, first of all. It needed to be somebody with decades of industry experience, because this is where we saw none of us had those decades of semiconductor experience, which in this industry, you look at the CEOs of semiconductor companies, and most of them seem to have all worked together as colleagues at Fairchild Semiconductor back in the day. And so not having that profile, any of the three of us, we thought at some point it would be great if we could attract someone who has those relationships, who has decades of experience in the industry, but who also can be nimble or flexible enough to be excited about our vision and wanting to execute that. So yeah, it was tough criteria. And really early on, we had our eyes out. These advisors, the people who, I was bringing in as advisors who I was talking about earlier, each of them, we were really vetting to see, could this be our next CEO? Oftentimes we wouldn't tell them that we were vetting them for that, but we were just getting to know them through that relationship. Many of them didn't agree on our vision of the company and would advise us to do something different. And that was a X, okay, definitely not our future CEO type thing. And we expected that we would eventually have to hire a recruiting firm to do an official search. We were actually all really surprised when we didn't have to do that. So what ended up happening was one of our advisors called me up one day out of the blue. And this was one who we had told that we wanted to hire a CEO if we could find the right fit. So he called me up out of the blue and just said, "Hey, Alex, I've just found out that one of my former colleagues from Intel just left. He's looking for his next thing. He's one of my favorite people I've ever worked with. You have to talk to him." So I'm like, okay, I look up his profile. Okay, he led high performance computing at Intel. Interesting. That's very relevant. Oh, he was CEO of Penguin Computing. This is one of the major suppliers of supercomputers to the US government. Very interesting. Okay, let's have him in. So I had him in and just sat down with him for, it was probably a couple hours. And I had never seen anyone pick up on the vision of the company and the technology so quickly. He was just very clearly brilliant. He got it. And he had lived the pain point that we were solving because he had spent so much time in the semiconductor industry and in the supercomputing sector in particular. So he had lived with that bandwidth bottleneck that we were solving, and he understood the value of what we were creating. And he was right there with us with the vision. So I got really excited from that first meeting, and I immediately told Mark and Chen, because I had no idea what to think at first. I wasn't going to waste their time on somebody who probably would not be interesting. But after that meeting, I was like, guys, you have to meet this guy, Mark and Chen and Vladimir, actually. And so they met him. I think they were probably assumed, not expecting much from the first meeting, but then got very excited as well. It was interesting because it was actually, I met him right after we got that Series A term sheet. And so it was tough navigating that conversation with the lead investor for our Series A, Playground Global. We had to kind of navigate carefully how to bring it up with them because we wanted their buy-in. If we were going to hire this guy and bring him in as CEO, they needed to be supportive of that idea. But we also didn't want to bring it up in a way that would make them wonder, what's going on here. So after we signed that term sheet, then we told Playground that we were just considering bringing in a new CEO. And the initial reaction was, wait a second, we're investing in you as a founding team. What are you talking about? But we were like, we understand, just talk to the guy, see what you think. And we would love your input on whether you think he would be a good person to hire. We kind of brought them in on the process, and they did their own vetting as well. So what followed was a very long period of a lot of vetting. We wanted to talk to every type of person he had ever worked with, people who had reported to him, the people he had reported to, people who were kind of peers with him, investors, people who were on the board of every type of relationship he had had in work. We wanted to be talking to people. Playground even helped us with some vetting that wasn't his own references, just kind of people they knew who had worked with him, which was great. All that to say, we were very, very careful. We didn't want to bring in somebody to lead our company who wouldn't want to lead the company in the direction we wanted to take it. And we found that with Charlie. He's extremely thoughtful. He really cares about the vision of the founders. So I think we all just feel really lucky that we stumbled across him.
Oh, congratulations on finding Charlie. There's so many things I can pick out from that conversation we just had. First thing is, this topic comes up with VCs, I think, more often than not, about changing the CEO. Did that conversation ever come up in any of your conversations? And how did you deal with it?
It did. And I immediately just decided not to work with that VC. It never came up with VCs who invested in us, but it did sometimes come up with VCs who we were pitching to invest in us. And if they ever brought that up, that was it. I didn't want them to invest in us. I think there are two different approaches to venture capital, and VCs can basically fall into two camps. One is the camp where they want to be a little more active as investors, and they want to have a little more control in the company. And you can see what camp the investor you're talking to falls into when you see the term sheet. If they have more control type provisions in the term sheet, they want more seats on the board, all those types of things. I think it's a more old Silicon Valley approach to venture capital. And then there's kind of the newer approach to venture capital where it's The VCs tend to have been founders themselves in the past. And the terms you'll see in a term sheet will be pretty hands off. Maybe they'll be like, oh, I'll take a board seat or leave it. I mean, they'll usually want a board seat, but they won't ask for nearly as many controlling provisions in the term sheet. And really the message that they're sending is, you're the founder. You know best what to do for your company. We're here to support you. But ultimately, you know the right call, and we're just here to help. And so that's the type of investor that I tried to always go for when fundraising at Ayar Labs. And I steered clear of the ones who wanted more control, because I do believe everything has to be driven from the founders. The founders do know best. They're living and breathing it. They're spending every day doing it. Whereas an investor is always just going to be spending a few hours here and there on it. So they won't know it nearly as well as the founders.
I'm learning a lot here. I'm enjoying this conversation so much. Let's shift gears and talk about partnerships that you had to build over a period of time with companies like Intel and others. Talk us through the process. What good partnerships look like? Somebody just talked about it in the last podcast. It took about 7 meetings for partnerships to happen with top level folks. Any insights into good practices, best practices that you learned from?
Whoever said that about 7 meetings was not in the semiconductor industry.
No,
because it
not
takes
in the space.
far more in this space. Part of it is because products have such a long development cycle in this space. The planning starts 3 years before a product goes out for any of these companies. And then the vetting for a new technology to go into any product has to happen well before that. But part of it is also because there's been so much consolidation in the semiconductor industry that there really are just a few very large players. And so these organizations are huge. And so huge organizations don't move very quickly in general. And there are a lot of stakeholders who need to be bought into anything. Yeah, patience, which is a hard thing to tell an entrepreneur, because entrepreneurs are the most impatient people I know, myself included. I'm so impatient all the time. I just want things to move forward. And that was not going to happen with Ayar Labs. We started building relationships with companies like Intel back in 2015 when we founded the company. We started having meetings and telling them about our technology. And so yes, having that expectation that it will take a long time is definitely one thing. Another is that in our case, a lot of the companies that we were looking at partnering with also had their own research efforts in silicon photonics. So they were directly competitive to us as well as being potential customers. And so that was a whole other thing to navigate in building partnerships. How do we build trust with a company that's actually directly competing with us?
How did you do that?
Carefully. We ended up realizing that, especially with such big companies that have so many different things going on, they oftentimes already have a lot of safeguards in place, meaning firewalls between different departments to prevent information sharing. And so we could leverage those firewalls to build up enough trust with the departments we were working with and trust they would not share information with the departments that are competitive to us. So being very deliberate about that was important. And then there are other things like you don't need to share too much about a technology when it comes down to it to get by. We need to show results. We ended up kind of coming up with this mantra of talk about results, not process or the technology itself, especially when someone technical was going to be in a meeting. And it was really important not to get them on a roll, just talking about, oh yeah, this is how, like explaining exactly how we built the thing. Instead, just, hey, here are the results. Look at them. They're peer reviewed. It needed to be what the conversation was. And so that there wasn't much to steal if it was a competitor in the room. But, they couldn't deny those results that we were showing.
If they do bring up the subject, like if they want to dig deeper into that technology, just not the results, how do you deal with that?
Oh, it has been such an eternal question. We had lots of ways of dealing with it over time. Where we ended up settling, which I think is the right answer, was we just said no. We said, here are the results. We've told you everything we can about the technology and take it or leave it type of thing. If you can't make a decision on whether to partner with us based on these results and without knowing more about how we arrived at them, then too bad. We can't share anymore. And oftentimes they'll stop there and they'll say, you know what, actually, we are comfortable moving forward. So it just takes having a little guts, basically.
Yeah. As a first-time founder, like a lot of things that you mentioned are like very gutsy. I'm so glad you did what you did. What prepped you to do these things so well? Like I said, you are still one of the most confident CEOs that I know of. So I'm trying to learn here.
I think I just have this tendency where I talk about all the hindsight learnings and the positive things of what we did. But oh my gosh, in reality, it's been an insane roller coaster ride with ups and downs. And we were not doing all these things so well along the way. It was a lot of trial and error and learning. Like I said, I'm sure we shared way too much about our technology in early on meetings. Thankfully, no one's replicated it yet, but they probably could have with the amount. No, it's very hard to replicate what we do. So thank goodness they're even if we do some oversharing, it's still very hard to do. And we didn't find that balance until years in. And the same goes for everything else. The fundraising, it was trial and error, realizing I shouldn't be talking to these investors that are never going to invest in us in the first place. So it just takes doing it and always reminding yourself that no one has ever done what you're doing before. You are the first one doing it. So any advice that you're getting, even if it comes from super smart people who have tons of experience with startups, they've never done your startup. So trust your gut, trust what you know, take advice, seek out advice, but in the end, trust your gut and do what feels right to you.
Great advice. Before my closing questions, paint a picture of all the areas that you think your technology could do wonders. It's hard to imagine for human beings, I think, in general, at least for me. Just like show what's the pie in the sky look like 10, 20 years down the lane if people are using this, different areas that could benefit from this.
Yeah. So to start, it's, like I said, the communications between chips. And what does that actually mean? So until now, we've been architecting data centers and supercomputers essentially by taking the server, like the computer that used to sit under our desks before we all had laptops, right? When you had a separate monitor from your computer, that thing, we basically took that, turned it sideways and stacked it a bunch of times in a big warehouse. And that's what a data center is. It's really not optimized for the era of big data that we live in now. And so the first product, what it's doing is making it possible to re-architect the fundamentals of that machine. Instead of having a processor right next to a memory chip with super short electrical connections between them, we're making it possible to have big pools of processor chips and big pools of memory chips, and then these super highways between them, which is just a fundamentally different way of building that data center from the ground up. The first place this will have big impact is in artificial intelligence, AI, and machine learning, and supercomputing, because that's where there's really a strong need for this technology. Next, it'll just roll out across all data centers because it's fundamentally more efficient and makes data centers faster. And then, I'm oftentimes asked, will it end up in our devices? Will it be in our phones? And it's really a question of where in the phone is there a need for that kind of data movement? So when it comes to things like virtual reality, augmented reality, there is a huge need for very high data speeds and good energy efficiency in those pieces of communication. So it could be hidden in a phone or some kind of gaming device in the future. And then longer term, it goes back to this concept where I was talking about how right now the research is still in university labs, where we could use this platform where we're manufacturing photonic devices on the same chip where we have electrical devices to make all kinds of things. So it could help us make much better smart sensors in our smartwatches, for example. LiDAR is the technology that's used for self-driving cars, and you'll oftentimes see this spinning thing on top of the car. With our technology, you can integrate all these big, bulky physical parts in the spinning thing into a single tiny little chip and put one chip on each corner of the car so that you don't need the big clunky spinning thing and all these different components. It's just one little integrated thing that you can barely see. So those are just a few examples. Medical devices as well have a lot of sensors. You could take really big medical devices and miniaturize them and make them much more accessible to the rest of the world where they don't have the resources in hospitals that we do. There are so many areas that could be transformed by this technology, and that's why it's so exciting.
We are living in some exciting times. Thank you for sharing that vision. Now on to my favorite closing questions. I asked all my entrepreneur guests here, what are a couple of mistakes you would like others to avoid? Any lessons from building Ayar Labs?
I would say that one I talked about a little bit before about trusting your gut. So a mistake we made early on was we took all the advice we received, especially from venture capital investors we were pitching, too seriously. And we would pivot our pitch deck and our business plan almost on a daily basis based on the feedback of the day.
Oh my goodness, yes.
And eventually I learned to have that confidence that, okay, wait, these guys are smart. They've seen and been through a lot of different startup stories, but they've never done this startup and I know better than them. So I'm going to stick with, even though they say this one said I should be raising more money, I'm going to stick with the amount of money that I think is the right amount of money to raise. Or even though this one says I should be raising less money, no, I'm going to stick with the amount I think I should be raising. And I'll just go pitch another investor who doesn't have that feedback.
Amen to that.
So yeah, I think that's the number one learning that I've had.
If there are like one or two people who played a significant role in helping you in this journey of Ayar Labs, who would that be?
Oh, so many people. And I almost hesitate to mention anyone because then I'll feel like I'm leaving out key people. But I would say one person who's been really helpful from early on is Dan Armbrust. So he was the original founding CEO of Silicon Catalyst, the semiconductor-focused incubator that we were a part of. He has just been a really helpful advisor over the years. He's joined our board now, and he just always has good advice. He has a lot of experience in semiconductor companies and has helped us navigate relationships within those companies, and just been a really valuable thought leader to have us at our side as we grow the company. I would say Bill Aulette, who is the leadership of the Entrepreneurship Center at MIT. He created both the Energy Ventures class, where I met my co-founders, and he also created the MIT Clean Energy Prize. So he's just fantastic at creating these venues, these safe places for engineers and business school students, people with different backgrounds who speak different languages, to get to know each other and build that trust, which is so key. It was so important to Ayar Labs even existing. So I'm really grateful to him as well.
Wonderful. Alex, this has been so much fun. I learned so much about startups and dealing with the startup life, and I'm sure my guests are going to enjoy this and learn as well. Thank you for sharing the lessons. Thank you for being a guest here today.
Thank you so much for having me. It's been a fun conversation.
Thank you for listening to this episode of the Lab to Startup podcast. You can find links to the resources and programs mentioned in these episodes, connect with Naresh, or subscribe to this show at labtostartup.com.